Okay, great. Okay, so to access, I'm guessing everybody knows how to go about this right now. To access the server, go to myapp.rgu.ac.uk. So log into your school account. Yeah, so you look for SQL Management Studio. You should have installed the receiver before, but if you haven't installed it, it would give you the link to download and stuff. So. But I guess everybody has already done that, so that's fine. Okay, so we're here. I'll also bring up campus module. Up one. Okay. Okay, so you have your database. So we'll just go through lab one together, I guess. I'll just make some explanation if there needs to be. The aim of this lab is to introduce the SQL server. Okay, basically, before I do this, I just want to, at least to some extent, I guess to you guys have done this to some point. So I just want to take a bit of time to explain what we're actually trying to do here, right? So basically, you have the course is about database and database management, right? So what is a database? A database is a collection of data, like where we store data, where we a place where we can have our data stored and organized, right? And what is a database management system? That is a software that is giving us the ability to do that. Please don't write that inside the exam or read what is inside the lecture notes to write down. I'm just giving you the practical explanation of what it is. The database itself is the collection of your data. Whereby the database management system is the software allowing you to save your data. It's just like Microsoft Word and what you are typing. What you are typing is the data. Microsoft Word is the software allowing you to type. So when you talk of database management system, you're talking of a program or a software allowing you to save, organize, and interact with your data. While the database itself is the data, right? Is the collection of your data. I hope that makes sense. Okay. Sorry, just a minute. Okay. 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 So you have. Sorry. Hello. Okay. So basically, this course will be talking about the database and the management system also. So back to what we're doing here. The aim of the lab is to introduce you to SQL Server. So basically, for most database management system, what is used for interaction with your data, like I said, there is difference between your database and your database management system. Now, the system used for interacting with your data, like, it's called SQL. It's actually a language, structured query language. So basically, that's the whole idea of this class, to be able to interact with your data. You save data, you see data, you delete data, you update data and stuff. So for most DBMS, the the what gives you a connection between your data is like the language you use in interacting with your data is called SQL. So we've talked of database, we've talked of database management system, we've talked of SQL. I'm just trying to lay those things down so that when we see them uh while we're working, we know what each one is. SQL is the language used for interaction. Database is the data collection itself. Database management is the software, is the program that is actually storing a collection of data. So that's it. So for this course, the database management system we'll be using is SQL Server Management Studio. There are different types of DBMS, database management system. There is Oracle, there is this one we're using, SQL Server Management Studio. I think this is from Microsoft. There is MySQL. I guess some of us are familiar with it. There's Postgres SQL. There is there are a bunch of them. There are a bunch of them, right? So, but for the purpose of this class, we'll be using SQL Server Management Studio, SSMS. And good for us, the school has provided us with a server, which we'll connect to in a minute. So thereafter, in part two, we explore key database concepts, tables, primary key relationship, and database integrity rules, first by studying an existing database, what alone, and thereafter by developing a database for quick band delivery, blah, 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 blah. Microsoft SQL Server Management Studio is a client that includes an easy graphical, blah, 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 blah. So here gives us the authentication data to connect to a database. So database engine, your server, and that. Then this is the server name. This is the server type, and yeah. So we can just connect, and it's going to give us a couple of things. So now we're here. If you've not done this, you can follow along, but I guess most people have done this. So basically, there are three interface. This is the main interface, but there are three different sections here. There's this top bar, there's this one here, and there's this empty canvas here. Now this top bar is just your normal explorer, like for this particular window. This is your normal explorer. This is your database explorer, like your Windows Explorer, your database explorer, and your canvas, like your a playground, kind of, where you can do stuff, and we'll come back to each one of them very soon. This is where you can query your database graphically. This is where you can interact with this particular app, like Microsoft SQL Management Studio itself. And this is where you can interact with your both the DBMS and the DB itself, with commands, SQL, and others. So you have your, so they just explained it. You have your, there are a bunch of keys there that we'll look at in a minute, but we'll get back to that. your Object Explorer, your Database Explorer, then your Canvas, which is also your document windows there. So about database now, for every database management, anytime you're working with data, right, there are two languages you will be interacting with at the same time. We've talked of SQL. The other one that we didn't talk of is the DLL itself. Database. I forgot about it's the database management system specific language. Like this, I am sure you guys have been seeing use your use QGvan underscore something since. This is not SQL. That use is a database specific, a database management system specific keyword. Like that use is just Microsoft SQL Server Management Studios keyword. For other databases, it might be different. For Postgres, for example, okay, this use here is saying connect to what alone. So what we are trying to say when we run this command is that, okay, for everything I will be doing henceforth, I want it to be done on what alone, right? I'm connecting, like right now, I'm just in the server. Yeah, I'm in the server, but I'm not actually in any database. I have a bunch of databases, right? If you go to database graphically, you should see a bunch of databases. So I have a bunch of databases and I don't just want to be working in everyone at the same time. I need to connect to a specific database. I feel okay, this is the database I'm working on. So that is where the use a particular database name comes into play. But when you're dealing with other database management system, PSQL, for example, PostgreSQL, for example, it's not use, is \c, then what alone. So those are not actually SQL. SQL is a universal language. Any database management system you are typing SQL into is going to take it. We'll get into SQL in a bit. But anywhere you are typing, any database management system you are typing pure SQL into is going to take it. But there are some things you will see in this class that are not SQL, which means when you get to other database management system, it might not work. So in that case, you can just easily go to Google and do something like this. Alternative, or just connect to DB in Postgres, right? So it says blah 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 blah. Coming. This is actually not true. Postgres. You can see it says there are multiple ways to select a or access a Postgres database, such as command prompt, SQL, blah 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 blah. Type /c followed by a database name to select a database using PSQL. So in our own case, it's use what alone. In the case of Postgres, it's /c what alone. So that's the difference between SQL and database system language itself. There are database specific keywords, things like this. So note that not everything you see here is SQL. Well, when we get to the SQL bits, I'm going to actually specify that those are SQL. So now let's do this. We're trying to connect to what alone, right? Execute. It says command completed successfully, although nothing is actually going on. But right now I'm open. We are in what alone. So the use statement typically does not return any results. You can see from what we got. However, you must always use the database before you can access any data in it. So if you come in the morning and you just start typing, oh yeah, create a table, create this, create that, then it's not going to work because you are not in any database. So the first thing you want to do is either create a new database and use it, or if you have the database before, you can just say use Waterlearn. If you don't have the database before, you want to run a create first, which we'll get to in a bit. Notice that any feedback associated with execution will be displayed in further panel below the document windows. Sorry, one thing before I continue. This material is prepared by RGU. So this is not my material, just a disclaimer for you and copyright purposes. It's not my material. I'm just solving it. It was prepared for RGU by RGU. Thanks. So explore the Waterlearn database by traversing the tree structure. In particular, pay attention to table attributes. You can play around with this on your own time. All they are telling you to do is to play around with this particular side of the stuff. So if you like Waterlearn, for example, everybody has access to that, so you can play around with the stuffs here. So these are the tables inside it, and you can play around with, see anything that you can see there, and you know, don't, yeah, you can't, except you are deleting stuffs, right? If it's not your table, don't delete stuffs, but every other thing you can play around, right? You can do new, you can do anything, but make sure you are not deleting people's stuff, so it won't break anything, or when you delete, it's gone. So make sure not to delete, but you can play around with every other thing. Don't be afraid, nothing will break. Yeah, so let's go here. Learning about DBs and tables. But what if you don't know the names of the available database? Equally, how does the client application obtain the list of available databases that are displayed in the drop-down list? So basically, I might not be able to read everything, but I will just be explaining what they are trying to say here is, so you came in the morning, you forgot the name of your database, and probably you don't want to use this. You could easily execute data sp data bases. This is going to list out all the databases in the system. Yeah, all the databases you have access to, not in the system actually, all the databases you have access to, because there are a bunch of other databases in the system that I don't have access to. I can't even open them. It's going to try and error if I try to open them because they're not mine. There are some sort of security policies in place regarding that. But any database you have access to is going to show up. I think I created all these ones. I have access to these ones. I don't know. Okay, maybe the one that created this one also. So I created some. I think the owner gave everybody access to it. So everybody should actually see all these Waterlearn and stuff like that. So they are just security policies. So this is just to execute, like bring out all the databases. We'll be seeing this execute a lot in our work. There are procedures actually. I think we talked about that in lab 4. They talked about it in lab 4. So there are procedures that have been written now. This execute XP databases is actually doing something behind the scene to bring out databases for you. Well, it's probably a long command and they've shortened it to something like this, like just to execute. It's just like print out all the databases I have access to. So that's how that works. Now, going back to database. Now, database, like I said, is a collection of data, right? Now, let me pick it from the top. There is database servers. There are database servers. That's one. You want to understand what a server is. A server is a collection of databases. A server is a computer. That's just what we are familiar with. A server is a computer. That's just it. So what you are seeing here is a computer holding bunch of databases, different databases, and a lot of it. So a database server is just a server. It's just a computer holding a lot of databases. And now that takes us to database. Now a database a is a is a system. It's just a box holding a lot of tables, right? Is holding a lot of tables. Say a practical example, right? You can say RGU as a database, or School of Computing as a database, and inside that database, they have several tables. They have the student tables, they have the student table, they have the building table, they have the lecturers table, they have the courses table. So inside the student table, you're expected to find things like Anthony, things like um Genius, things like Muji. Like you find student inside that student table, and inside the lecturer table you find people like Atem, you find people like, I don't know, Rob. You get, so a database is a collection of table that are related, like they are for a particular system, right? It's you don't want to keep tables from uh University of Aberdeen inside the tables of RGU. That is not correct. And if, let's say, each school in RGU is having their own separate databases, let's say School of Computing is having their own database, Grey School of Arts is having their own database, you don't want to mix up their tables. So the only tables you find inside School of Computing are tables relating to School of Computing, right? So we can say RGU is a server. Let's use it that way. RGU is the school, right? As RGU is our computer, is the one supplying us with the server. So RGU is our database server. Then we can say, okay, each school, School of Computing, Great School of Art, School of Business, those ones are databases, right? So you have several databases. So you can have RGU, the database will connect to here right now. Let's say this is RGU. Then inside it, we have School of Computing, Great School of Arts, School of Business, School of blah blah blah, any other schools we have. You get, then inside each of those databases, we now have tables. So in School of Computing, we have several tables. We have the student table, we have the lecturers table, we have the buildings table, we have the classes table, we have the lectures table, we have the courses table. So you have server, you have database, you have table. I hope that is making sense. So to access the tables in a particular database, you can say, use this command, right? Execute. This is a bit long, but I'll explain why it's that long in a bit. Execute SP tables. Don't forget we are connected to Waterloon, so the tables will be, okay, we'll actually see a bunch of, if you execute this gives you, yeah, just the tables in Waterloon. Yeah, that's because we are connected to Waterloon. Waterloon. So this gives you, and you can see basically the only thing you can pick out here are these ones: customer, employee, loan and occasional loan type, payment. All these other ones, you don't necessarily need to know where they came from, right? They're actually not tables, they are views. So that's why we have these other long stuffs. This is just telling it, uh, just a minute, yeah. So I think it takes the table name, the table owner, the table qualifier, the table type. Basically, it just takes a couple of arguments. I don't know what this is. This is a procedure, right? So except you read the documentation, somebody wrote this and kept it in the system to make things easier for us. So basically, for the purpose of this class, you don't really need to know much about. You just need to know how to use it. So basically, you have execute SP tables, right? That collects a bunch of arguments if you don't want to see everything. So this is the database owner. This is what's alone. This is the database you want to get stuff from, and this is the type of the table type you are interested in. I hope that makes sense. So your command, right? Let me see if I can get what this is. Start procedure to learn SPS with table name, table owner, table qualifier, table type. So this is table qualifier, but I'm not really sure what this is. But this is database owner, DBO. This is the table itself, the table name, and this is just telling it give me table type of table. So it won't show if you change this. If you change this to view, this is what you see. If you use table, this is what you see. So if you run only this, then you get your just the tables inside your stuff. So let's just play around with something, right? Okay, we've not gotten to creating tables yet, so let's just go on. We'll use that RG example as a bigger example. So let's just continue. So now back to what I said, we have a database server, we have the database itself, then we have tables inside the database. Now inside the database, we now have columns. Right, back to your Excel. Back to your Excel. So yeah, right. So take this as your table. This is like your table. Your table is going to have, let's say this is the student table. Your table is going to have columns, right? Name, email. Let's say this is the student table. Student ID and stuff, right? Now this is your columns. So back to what we were saying before, we have database server, database. Let me just use. Sorry. You have database server. Inside it, you'll find databases. Inside the databases, you'll find tables. And inside the tables, you find columns. Your database server is made up of databases. Your database is made up of tables. Your tables is made up of columns. So to view the columns inside each of these tables, then you use execute sp columns. So you can now say execute sp columns. I want to check the columns inside customers, right? So these are the columns inside customer. I think you can actually run it without any table name. No, you can't do that. So execute sp columns customer. If you let's just see everything. No. Execute. So we have customer. You can have employees. No. So we have employees. You have loan allocation. Loan allocations, loan types. All right. We have payments. All right. So each of the tables. Now, for each one of the tables, we can check the columns inside it. So these are the columns inside customer ID that created, full name, billing address, and stuffs. We can get that of employees also. These are employees columns. These are, so this column name is like, let's say we want to create this customer in Excel, right? This customer, now we can say this is our customer table. So inside the customer table, we have customer ID, we have date created, really. We have full name and blah blah blah, full name and the rest. So those are, all these ones like these are columns. Like they will see them in action in while we're working. So they are just columns that are in each of the tables. So that's SP column. So we've talked of SP databases for listing out the data, your own, like the databases you have access to. We've talked of SP tables that list out the tables in a specific database. And we've talked of SP columns that list out the columns in a specific table. So let's move on. Try SP columns command to list out each of the tables in DB. I think we've covered that. That's fine. Now let's talk of data types. If you were in yesterday's class, Java class, one of the first thing we talked about was data types. Now, for every programming language, there are data types, because basically every programming language, at the core of it, you're dealing with data, right? You're either collecting data, you are showing people data. So you want to, at every point, you want to know the type of the data. Same thing applies in SQL. We looked at some data types in Java yesterday. We looked at string, integer, float, blah, blah, blah. We have that same kind of data structure here. They are a bit different in name, but at the core of it, it's still the same, right? They're at the core of everything, data types. They are text, they are numbers, they are booleans, yeah, a bunch of other ones. But basically, at the core of it, there are those, right? So in every data type, you're going to find text, you're going to find number, you're going to find boolean. But in SQL, mean that we are actually dealing with data here, there are a bunch of other ones and a bit specific, right? So some of the data types you have in SQL are ints, date, time. I think they're understandable. Int is just whole number, right? Whole number, integer. Date time is for date time. Money is for currencies and stuffs. Bit, now bit is for storing yes or no, true or false. You get those one and zeros. So actually it's going to save as 1 or 0, but the whole idea is you're asking, are you a male? Yes or no. Are you in school? Yes or no. Are you taking 022, yes or no. So that's what bit is doing. It's a yes or no question. It's saving a yes or no answer. But the inside the database, what you see is 1 for true and 0 for false. Then there is decimal, which is decimal point numbers. Then we have characters, enchar, envarchar, and text. Now there is char, there is varchar, and there is text. Now the difference between the 6, like each of those n you see here also has the ones without n. Now I will start with enchar. Enchar means a bunch of character with a specific length. So if I say enchar 5, I'm saying anytime I want to save something inside a column marked as, you can see those data types here. So each of these columns must have a data type. Each of these columns must have a data type. So what I'm saying is, if I save any column as enchar 5, it must have character length of 5. Like if I save a column as, let's say I save the name column as enchar 5, that means I can't have Tony, I can't have Anthony. The only thing I have is probably Junus, because that's YUNUS, which is 5. I can only have character, a word of 5 characters. I don't know if that makes sense. Now going to envarchar, we have, let's say you have envarchar of envarchar 10, right? Or let's still stick with envarchar 5. Let's say you have envarchar 5. What you're saying is you can have a maximum of 5, which means you can have Tony, but you cannot have Anthony, because Anthony is more than 5. I don't know if you get this. Enchar here is a fixed length, envarchar is just specifying maximum. I don't know if that makes sense. Now then we have end text. Now the difference between this and this basically is character length. This can hold much more data than this one. You can check out the constraints on, you can check this link to check out the number of bytes, but the difference between this and this is the number of characters they can, like, you can have inside, right? So basically it's this and this are the same thing. If you specify in text, you're saying, okay, I want a text field that is very, very large. I can save something very, very large inside it. So that's it. And yeah, you can read these on your own time. From your reading, what do you think is the difference between enchar and envarchar? This holds a fixed length of characters. This holds a varying length of characters, which means the only thing you are specifying here is the maximum. It can be more than 10. It can be more than 20. So if you do envarchar 20, you are saying anything you are entering must not be more than 20. It could be 1, it could be 2, it could be 19, it could be 20, but it can be 21 in length. So that's the difference. Given attribute, quantity, and price of the product, which numeric data type will you use for each? Quantity, that will be decimal. Price, that will be money. So when might you use the attribute varchar as opposed to envarchar? Envarchar, like I said, the n here is a constraint that is telling it, okay, you need a particular length. You're telling it shouldn't be more than 20, it shouldn't be more than 50. And for varchar, you're just saying, okay, just give me a text field, anything they feel like entering inside. But it also has its own inbuilt constraints. Like, I think there is a maximum length you can actually save in a varchar. You can check that out if you click on this link. There's a maximum length, but here you're actually specifying that, okay, I don't want, I think 255 or 256 or something. But here you can say I don't want more than 20, I don't want more than 30. But here, there is no constraint. You can enter as much as possible as long as it's not much more than what the data type can actually contain. So you might use this for addresses, right? Because you don't know how long some people's addresses can be. If you see addresses in Nigeria, you will want to cry. Don't mind me. Uh, and
Hello.
this is
Sorry to interrupt you. Can I say something, please?
okay.
Okay, with regards to the VACHA and NVACHA, the major difference, other than the major difference that makes it carry an N is because of Unicode characters. So for NVACHA, you know that there are people that probably we all speak different languages. You understand? So somebody might want to spell their name in Chinese language. You understand? Another person might want to spell in English. Another person might want to spell might also want to put other special characters. You understand? So the NVACHA allows multilingual entry. You understand? But for NVACHA, it's just simple English. And for VACHA, it's just simple English. You understand? It's just one language. So if you put VACHA and the person is spelling in another language, it's not multilingual, the person uses Unicode characters, it will not be able to save, it will accept it. You understand? So it's Unicode um the Unicode allowance that makes that NVACHA superior over the VACHA. That's just all I wanted to say.
Yeah, yeah,
I'm so
that's
sorry for interrupting.
yeah, I get that. I get what you're trying to say. It's just because if I go into that, then I will need to start explaining what Unicode means, and I don't want to do that. That was why I didn't actually go into that. But Unicode is one of the differences between these two. Character length is also one of the visible length is also one of the difference. But one thing I thought about was if I take that as my explanation, then I will have to start explaining what Unicode means, and I think it's beyond the scope of this class. That's why I didn't actually go into it. But you are very right. Unicode characters and non-Unicode characters are one of the differences between the two. But yeah, that makes sense. Thank you.
Okay. Okay, can we okay make it simple for everybody like this? Like in your Word documents, right? When you want to insert special characters, like maybe you want to insert a symbol you want to insert a symbol, you see Greek symbols, you see other special symbols like that.
Mm-hmm.
I don't know if anybody has noticed it. When you try to insert a symbol when using your Word document, that's Microsoft Word, MS Word. Could someone please respond?
Well, we are responding through the chats to avoid the
Oh, okay.
mic. Yes.
So that's what Unicode characters are, those special characters that you can find in your MS Word, just to make it easy and not stress our Oga to start explaining.
Basically,
Thank
Unicode
you.
characters,
Sorry.
like she's saying, they are characters you're not familiar with. I think they are actually they are not on your keyboard. They are not on your keyboard. Yeah, they are not, but they are characters you might have seen. Like they are characters, I'm sure everybody has seen it. They are just not familiar with it. They are characters you've seen that you're not familiar with. This was why they want to go into it. Unicode characters.
I'm so sorry. Very, very sorry.
Problem. Okay, things like this, they're actually characters. They can be typed, but you can see them. Can actually, there are a bunch of them. Blah, blah, blah. So these are they're actually much more than this. No, this is not what I'm looking for actually. Hold on a minute. Yep. Mm, some of them are here, but they are much more than these. I'm just trying to see. No, you can just check out. Let me pick out this Unicode characters and Google. Yeah, you should be fine. So, really, yeah. So some of them you are familiar with. Yeah, things like this. They are just all the characters that are typeable, because I think the only thing we are covering, like the normal characters are covering, are English words, but there are other characters, Chinese characters, Japanese characters, and even characters that don't have origin. So, but there are much. You can check out this document in your own free time to understand the difference. But I think that's actually beyond the scope of the class. But what they're just trying to say here is just, I think basically one of the, according to the scope of this particular class, the actual difference they are trying to point out between the two here is length. If you read the document, the actual thing they are trying to point out is length, but Unicode characters is also part of the difference between the two. Yeah, so that's that. Thanks for raising that. What's the purpose of bit and how you might use it? The purpose of bit, like I explained earlier, is just for answering a yes or no question. And when might you use it? When you're trying to ask a question that has only a true or false answer. Were you in this class? Yes or no? Explore the use of date time and SQL. So you can check out these documents, click on date time and see different ways of using date time. You can have date alone, you can have date time, you can have time alone, and even date time itself, you can have different formats for writing it. When might you use end text and end varchar is almost like the same thing as the
commercial off the shelf too.
sorry, are you talking to me? Hello?
Please continue.
Okay. So end text, end varchar is almost like what we were saying with varchar and end varchar earlier. We still maintain there are still some other differences between the two, or for the scope of this class, it's still about the byte length, right? The number of bytes your end text to accommodate is bigger than what your end varchar will accommodate. End varchar, it's in the sense of byte, it takes little than end text. It's just all these n-char and blah blah blah. They're all about length of characters and length of bytes, kind of. So that's just. But for more understanding, just go through the link and you understand what's going on there. So let's go on. Developing the quick van delivery company database system. So this is where the real work starts. You have to create a database with quick van. So I'm guessing a lot of us has done this. So just for understanding, because I think if we are to do this, they won't bring out quick van inside the exam, right? What they will bring out is something else. So I'm thinking for a much more understanding, we can use a different database structure, but that will affect a further query. So we can just stick with it though. But I was thinking we can use a different database structure like the RGUO I was talking about earlier, but it will affect query down the line because the query are specific to QuickVan. So let's just stick with QuickVan. So we'll progressively develop a database for the QuickVan delivery company who runs a delivery service. Here are some details about QuickVan service. They will deliver letter package, blah 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 blah. So basically, the following is a detailed description of the attributes of 5 tables that makes up QuickVan. You have the driver table and you have the columns under it. You have the customer, you have the columns, you have the delivery, you have the columns, you have invoice, you have the columns, you have payslip, you have the columns. Now, creating the tables. The first thing is you want to create your database. You want to create your database, then you want to go into that, you want to connect to that particular database. This is just an execution statement to tell it that has been done or something. So let's start. Like I said, from here, right? The first thing is your database server. You've connected to it. The second thing is getting your database. The third thing is getting your tables. And the fourth thing is your columns. So if you look at it, you create your database. You create your columns, really. You create your columns. You create your table. You create your table, that's driver. Then you put your columns inside the table. So that's how it goes. So we'll create, I think there is an explanation of how to, okay. Yeah, this was what I was looking for. So, but for the class, we'll just say create database QVan tutorial, right? Go and use QVan tutorial, right? You can execute one by one. You can execute everything together. That's fine, as long as you know what you're doing. Okay. Okay, let's do it separately then. Execute. That's fine. It's just really. Okay, so the good thing about everything computer science, everything programming or computer is, as you are doing it, you are getting your knock, you are getting your error immediately. It's not like you are waiting for somebody to come and report an error. As you are doing it, you are testing it, you are getting your errors, you are fixing it. And I think that's how the exam will be also. You are not writing on paper. So while you are doing your stuffs, run it, see the response you get, tailor the response back to what you actually want, and you will be fine. So let's continue. Now, I've created our table. Our database. We've connected to the database, so we can continue. Note you can highlight the command you wish to be executed before clicking it. That's what I've been doing since morning. If you click on execute, it's going to execute everything. Like if you execute without highlighting, it's going to execute everything in your canvas. If you highlight a particular section and you execute, it's going to only execute that particular section. So here the create command creates the database QVan and use test SQL, like use here test SQL that QVan is the current database and not any other database such as master blah 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 blah. SQL server utility interprets Go as a signal that they want to send the current batch of transact SQL statement to This is just like, I don't know, it's just, you can, if you understand what it's about, it's not really a big deal. And even if you don't have it, it will still run fine. It's just committing something into memory or something. So, well, that's our own issue. Our own issue here is we're done creating our database. Now we need to talk of our table. Don't forget, we are here now. We've gotten this. Now we need to talk about this one. So creating your table, it's the same way. You have create table, right? Then what's the table you want to create? Don't forget, you are now in, because you've executed this, you are now in Keyvan tutorial. So anything you are doing will always be in Keyvan tutorial. The table we are creating now is driver. Then your normal bracket. Then inside it, you can now have your your column. So from what we have here, they said we have driver ID, right? So driver ID. Now, how column creation works is you have your column definition. Okay, let's see table definition. Table definition. You have create table. Create table. Table name, right? Column name. Data type and constraint. Now, constraints could be anything as not null, as unique. We'll see a bunch of them in the future, but one thing we are familiar with right now is not null or null. So you have your table, you have your column name, you have your data type, and you have your constraints. And you can have more than one constraint, or we'll see that later. Let's just stick with what we have right now. So you have driver ID, you have, that's a column name. The data type is nchar with field size 4. So nchar with field size 4. For SQL is not case sensitive, but I would recommend that when you are writing your exam, you write with the same cases using it. So when you're using system keywords, use capital letters. System keywords, create table, nchar, all data types, and all these system keywords you use. It's just a recommendation, but everything will still work fine. But you don't know what the person is thinking when they are marking it. So just stick with the same way they wrote it in class. But anyway you write it, whether you put everything as capital, you put everything as small, or you do it the same way it's done, it should be fine. It will work, and your mark too should be fine. I'm not the one that will mark it, so I don't know how the person is going to mark it. I asked him in class though, and he said, yeah, it doesn't matter that as long as it works. So I guess that's fine. So driver ID nchar 4, and now it says we should use not. No, I'll come back to this in a bit, or can I do it now? I will come back to how this is generated in a bit, but let's just use it. Not no. Might not cover all the stores. I will just take the one that title, n varchar n varchar 3. So this is saying just 3 not okay, this could be null, right? This could be null, and we have first name. Let's just say first name That is n voucher 30, not null. So what not null means is when you are entering your data, let's say we want to enter our first data, which is Anthony, right? Anywhere we have this, when you want to enter your data is going to have a driver's ID, which is probably 1, title, which is Mr., and first name, which is Anthony, right? Now, when you are entering that data, this driver ID cannot be empty. That is what not null means. So you can't want to enter a driver and says, okay, we don't know his first name yet, we'll just leave it empty. It's not going to take it because there is a not constraint, there is a constraint on first name that is saying it must not be null. You get same thing goes for driver ID. You can say, okay, we're waiting for the HR to generate the driver ID, but let's just create it first, then we'll put it later. You can't do that, but you can do it for title. You can say, okay, we don't know if it's a male or a female yet, so you can leave it empty. You can leave this one empty, but all these ones with no constraints, you cannot leave them empty. So that's what this is doing here. So I'll skip the other fields and just go to this constraint. Now, the constraints, let me just type it out. So constraints, PK driver, using what they use, driver, primary key, driver ID. Okay, so what are we doing here? Now, there are a bunch of constraints in SQL, but the first one we'll be talking about is primary key. Now, when we talk of primary key, we are talking about a field that is making your data unique, right? When you were registered, everybody had a student number in RGU. Now, that RGU, you can't have duplicate of it. You can't have another person with my own school ID. It's not possible because I'm guessing the student ID on the table is the primary key. So if they try to enter another person with my user ID, with my school user ID, is going to reject it, saying, okay, we already have somebody with that user ID. That user ID is already used. Can you get something else? You grab. So this constraint is to tell each of the data that is coming in that this is our primary key. So anytime we want to reference Anthony, we know where to find him. Now, Anthony can decide to change his name tomorrow, and his number Anthony is now Tony, right? He even went and do change of name normally, that is no more even bearing Anthony, is now Johnson. That can be done, right? But even if Anthony changes to Johnson, his user ID is still going to be 1 because that's like his point of reference. In in an ever-changing world, you can always find Anthony on 1. I don't know if you get. Then if we enter Junus, in anytime you want to address Junus, whether he changes his name or he does anything to his name or anything happens, it's no more a male, it's not a female, you will always find Junus on 2. That's the whole idea of a primary key constraint. You're saying this is the point of reference for this particular data. And we'll get into putting in data, we'll see where that comes into play. So we can actually do that very quick. insert into driver. I guess you should have seen this in lab 2, so this shouldn't be strange, but we're not here yet. But it shouldn't still be strange to you because you should have seen it in lab 2. Insert into driver 1, Mr. Anthony, right? This is wrong. I know that. Oh, yeah. Oh my God. The table has not been created, so we need to create the table first. Create the table, execute. So we have the table. So if you go to execute, I'll just copy and paste. Execute. Qvine tutorial. Execute. Then we have driver. Here, I think this should work. Was here invalid object name driver. We have it already, so let's do that. Blah. Start into table manual. Insert SQL. Insert into phone book. Can insert without no, yeah, forgot something. Values, right? Yeah, forgot that. So insert into your table name, your values, and your data type. You can do this or you can do this. Insert into driver driver ID. To actually, I'm not doing this now. Do it in the next lab. Right here. Values. And this is going to be our values. So this works, but we don't need this yet. So we'll just run this, execute. So now if you go to your, forget about all these ones. I'm just trying to show you where the constraint comes into play. Select start from driver. Yeah, I have that. So now this is where the constraint comes into play. If I try inserting this again, it tells me violation of primary key constraint, PK driver cannot insert duplicate key in object driver ID, and the duplicate key value is 1. So if I change this to 2, even though I'm still entering Anthony again, it's still going to enter because it's not violating the primary key constraints. That's it. What this means is that, okay, we have another Mr. Anthony, that's fine. But this Mr. Anthony is different from this Mr. Anthony because of their primary key ID, their primary key, which is their driver ID. I hope that makes sense. That is where the constraint comes into play. So you can't have multiple 1. You can't have multiple 2. You can only have one of it. So that's constraint. Yeah. So create, you can go ahead and I guess you've done most of those things. So I'm going to work on deliver so we can talk of foreign key also. Yeah. So let's create the deliver table. So create table deliver, I see people they actually know what they're typing, but they're making the mistakes of brackets and they're just missing something. One thing to make you a good, I guess, everyone here is actually taking out the development class. So one thing that makes you a good developer is attention to detail. If you are reading something, like you are reading it like this and typing it out, and you are not typing it fine, imagine when you're actually not reading it and you're typing it from your head. So you should pay attention to detail. Every character, every word, every comma, every full stop, they have what they are doing there. So pay attention to it. Don't miss anything. Everything here is correct, but if some people have to type this out, it won't work. So please pay attention to detail. If you don't do that, you're going to have issues, whether you are copying somebody or you are typing it out yourself or you are even typing out the questions, you are going to have issues, right? Pay attention to every little detail. Same thing goes for reading questions, right? When you are reading questions, there are some times where there are specific requests in the questions. Pay attention to it. It's going to help a lot. So create table deliver. I think we have delivery ID, which is nchar7. Now, one thing before I leave this constraint, although it's actually not necessary, this driver ID cannot be null, right? Even if I remove this not null, it will automatically help you to add it. Your primary key cannot be null. So when you are entering Mr. Last in the year, you cannot say, okay, it's not going to accept it, right? So that's it. So whether you put not null here or you don't put it, it's still going to help you to add not null to it at the back. So a big deal. And all these places I add null, they are not necessary. If you don't put not null, by default, your column is null. So that's all these ones that there's no not null in front. By default there, you can decide not to put anything in vehicle. You can decide not to put anything in pickup, but you can't do that for all these other ones. You can't do that for delivery address. So driver ID, okay, delivery ID, driver ID, which should be nchar4, because we'll be referencing it later, so we need to be careful what we're doing there. nchar4, that should also not be null according to them. And I need anything else, I can just put, I don't know, any other thing I feel like putting vehicle, and what was the nchar10, right? Then I put my primary key constraint pk. Now this is just constraint name. This could be anything. It could be, but it's just good to follow a particular guideline, to follow a particular standard. So what they are doing here is anytime they're using primary, they are creating a primary key, they add pk underscore the table name. And they are creating foreign key, as we'll see in a couple of minutes. They use fk. And they are creating domain keys in, like we see in lab 4, they use ck. So it's just follow pattern, so you don't mess things up and it's readable for any other person that is coming back to read it aside from you. So anytime we are creating a primary key, we use pk underscore the name of our table. So pk underscore deliver. Then we are saying we are creating a primary constraint, which is a primary key, and the primary key is this particular one. Here we are saying is driver ID. For deliver, it is delivery ID. So delivery ID, right? So we have our primary constraint, we have our primary key. Now, one thing about this about this class, data management, is we're actually talking of relational databases, right? We're dealing with relational databases. So what do you mean by relational databases? Relational database means things are connected, right? So back to the RGU database we are talking about. We say we have School of Computing, right, as a database. Okay, RGU server database is School of Computing. So we have inside it, we have a bunch of tables. We have the student table, we have the lecturer table, we have the courses table. Now, the students and the courses will be related because we want to say, okay, this student is offering this particular course. That is where the relation comes into play. This lecturer is taking this particular course. So there's a relationship between the lecturer table and the what's it called? And the courses table. There's also a relationship between the student table and the courses table. You get? So those are relations. So how do you form that relationship between a delivery and a driver? Because a delivery will be made by a driver. So for every delivery you are entering into your system, you want to know which driver made the delivery, right? You want to know which driver made the delivery. So we already have a list of all our drivers. All we need to do is to say, okay, let's connect the delivery to the driver, to each driver that is making the delivery. So that is where our foreign key constraint comes into play. So constraint, right? Constraint, then give it a name. FK. You can, the way what they are doing here is the table itself and the connecting table. So FK, the name of your FK, sorry, constraint, the name of your FK foreign key, the FK key, the table you are referencing, right? And some bunch of constraints which I will talk about in a minute. So FK deliver driver, right? We're saying is a foreign key, right? And the key is referencing this. Now, this is where things might get complicated when you see other table definitions, like other. I think things are a bit simpler here, but there is a possibility that here they just put driver instead of driver ID, right? We still want to reference this driver ID, but in the table where they want to do the reference from, they put driver, right? Now the foreign key here is referring to the field we want to connect here, which is this. So if this is what you have, if driver is what you have instead of driver ID, then what you want to put is driver, right? Then references, driver, let's put it normally, driver ID. So you are saying you are connecting this driver to, like, the driver on the deliver table to the driver ID on the driver table. I hope this makes sense. You are connecting the driver ID on this driver on your deliver table to the driver ID on your driver table. I hope this makes sense. So then we have this on update, on delete, cascade, on update, cascade. Now, what I'll take this again. Constraint, your constraint, the name of your constraint, which is a combination of your main table and your connecting table, then foreign key driver, which is the key you want to reference, the field you want to reference, not the key itself, the field you want to reference in your main table, which is this, then your references, then the table you are referencing, which is driver, and what field are you referencing on driver table? You are referencing the driver ID. Then we have these ones on delete cascade, on update cascade. What this is saying is when I delete, okay, let's say Anthony made a delivery to made a delivery to RGU, right? Delivered something to RGU. When I delete that delivery, okay, Anthony delivered a bunch of textbooks to RGU library, right? When I delete Anthony from the system, automatically we don't know who delivered the textbooks again, because we don't have Anthony in the system again. So what this cascade does is, once you delete Anthony, it deletes that textbook that was deleted, or that was delivered also. I don't know if you get that. Cascade means when you delete a parent, all the child are dead. All the children are dead. So driver was the one that made the delivery, right? Once you delete that driver, the delivery is deleted. So that's what cascade does. You also have not set nulls. On delete, set null. On update, set null. What that is saying is, when you delete Anthony here, when you delete Anthony, then this driver field is going to turn to null. Although that is not going to happen here because we added a constraint that says not null. So that will throw an error if you try that. Well, if this constraint is not there, then if we delete Anthony and what we have here is set null, right? If we delete Anthony, then that delivery, that textbook I delivered to RGU library, the driver there, like the driver on it is going to be null because we deleted Anthony. That is what will happen. And there is also no action or something, but basically I think for the scope of this class, the only thing they are talking about is cascade. So we'll stick with cascade. So what cascade does is, when you delete a parent, it deletes all the children. That doesn't mean that if I delete the delivery, nothing happens to the driver. So we are saying Anthony delivered a bunch of textbooks to RGU library. If we delete those textbooks, that particular delivery, nothing happens to the driver. But if you delete the driver that made that delivery, then the delivery will be deleted. I hope that makes sense to everybody. So the driver is like the parent and the delivery is the child. So if you delete the parent, automatically the child is an orphan, and we don't want an orphan data in our system, so we'll delete the child also. But if we delete the child, well, the parent can still be living. I hope that makes sense. So we're on that. Execute, and that completed. And if you go to, I'll just refresh this to show, I just want to show my what do we have else? Yeah, I want to show this. Show that something like that actually. Okay, makes sense. What's the name? Qvan tutorial. Okay. So DB diagram, I'll say new diagram. Yes, I do. And give me everything, add. And you can see there's a connection between our driver, and our delivery. You get? So that's the key is coming from here and is being used here on the deliverable. So the key is called driver, although in the course it's actually called driver ID, like in the document it's called driver ID. So I just use driver to tell you, to show you the difference between this and this. All right, but according to, like I said, follow the instructions. So when you're creating yours, what you want to use here is driver ID as you are given. So when you're creating yours, what you want is driver ID, and your foreign key is going to be driver ID. So that's that. And you can see your schema diagram. Just right click on your database diagram, click on new diagram, and select the tables you want to show. Then it comes up. Then there's that. Then you can go ahead and create every other field the same way I created mine. This is the create. Just add other fields that you want. And this is the driver, this is deliver. For every foreign key, you just add this. Change this will be FK deliver customer. Then you have a customer ID in your system, in your columns, fields. And now note that and you can go ahead and have a foreign key for this customer. Now note something here. Get out. This enter for here cannot be different from what we have here, right? Because you are referencing the driver table with this particular code. So if you have 4 here and you have 5 here, you are going to have an issue with your foreign key. It's already telling you it's not even collecting it. I hope this makes sense. So the column definition for your field must be the same as the column definition for your reference. I hope that makes sense. So if you change this to 4, we should be fine. Yeah, that's it. So your column definition should also be the same. Is there any question? Hello?
Hello.
Okay.
Yes, please. I have. Oh, please just put it back. I have somewhere I can show you.
Okay. Yeah.
Yeah. So my first question is on the driver ID incha value, like the incha value. So I can see that you put is 4. It's not supposed to be empty, but here as you have added, you put 2. I just want to have the quick understanding. I thought the car value or incha value is supposed to be fixed.
Sorry?
From the driver ID, is this the 4 value that you have added, like the incha value, is supposed to be fixed? I just want to have a quick.
Yeah. I think I've made a mistake there. I've made a mistake with my.
Yeah, that's what I was thinking. Like.
Yeah, I get what you're saying. I get what you're saying. I might have made a mistake with my explanation there. Okay. Let's just figure that out together. Hold on. I didn't actually take note.
Well, I'm sorry, everyone, to go back.
No, that's valid. That's actually valid. I didn't actually take note of that. So let's just check out what the n is actually. Fixed size string. N defines the string size in bytes pair and must be valid from 1 through 5. Storage size is 2 times 9 bytes, blah blah blah. But the number of characters that can be stored may be smaller than n. Yeah, so I'm coming. Oh. Actually, right, this my initial explanation here is wrong. My initial explanation Yeah, my initial explanation here is wrong. It's not, this is not maximum and minimum actually. This is it's just the difference is the size of character. Like this is not like it's fixed. My initial explanation, please, if you're here earlier, take this again. I made a mistake here. Encha is not fixed. It's not like when I put 10, it must be 10 on the dot. It's not fixed. This one, too, both of these n are for maximum, right? According to what we have here. For Encha, the number stored must be smaller than n, and for n virtual, the number stored must also be smaller, maybe smaller than n. You get, it's not must, may be smaller than n, so it may be n or it may be smaller than n, but the difference is the size, the maximum storage size of the character itself. So here it's saying we can have a storage size of 2 gig. Let's just read through this again. Variable size string data, n defines the string type size in byte pair and can be from value of 1 through 4000. Max indicates the maximum storage size in n raised to power this. So one character, the storage size is 2 times n bytes plus 2 bytes.
Can we have the difference just in English, please? In normal English. I know what you. I can get what
Can
you.
I
If somebody
can I
can
contribute
chip in,
something?
yes, please.
Yeah.
Can I contribute something? Okay,
Yes.
what it's basically trying to say is that when you are using NVARCHA, right, for every it uses times 2 of the storage.
Mhm. Like
Yeah,
the
that's what it's saying
like
there in byte pairs. So where the other one is supposed to use like one byte, for the NVARCHA we use 2 times of that, 2 times of 1 byte. You understand? So where one is 7 for 8 bytes, NVARCHA is using 16 for 1 character string length.
So in normal English, you can summarize by saying the value is
you remember the Java class we had yesterday, right?
yes,
Yeah, we talked about float and
and double and yeah,
the precision between the two. Now,
yes.
float is bigger. I can't give you the values right now, and I think yeah, this is it. This is actually it here. So float is bigger. Float is bigger. Sorry, double is bigger. Float is smaller. So the same thing here. Nchar has a smaller byte storage space, and Varchar
Yeah.
byte storage space. And I think this is the value here. The misconception is because when using character defined in Unicode 0, blah, 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 blah. However, in Unicode, blah, 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 blah.
Sorry, excuse me.
Sorry.
Both
Yeah.
of them have the same character size, 4,000, 4,000, but one uses 2 times for each character string.
Yeah.
That's
Can you hear me?
NVARCHA.
Yeah, I can hear you. I can hear you.
Okay, so basically, I just want to understand something for the NVARCHA thing. How exactly does it count? Because I encountered an error yesterday when I was working on the tutorial too. That's the self-tutorial. So I was trying to populate a table, and then I add the value of 20 for that NVARCHA, but it wouldn't take it, saying it was maximum. There was more than the maximum. So I had to do 30. So I want to understand, how does it count? Like, how does it do the input?
Sorry, can you come again with that example you just gave?
Okay. On the, like, I was trying to populate a table on tutorial 2. That's the lab. There was a self-tutorial there. Now, on that NVARCHA,
This
where
one.
you assign the size of the size of whatever string you want to put
The
in.
field size.
Now, I used 20. Do you
So it
understand?
puts 20 here, right?
Yeah, I
I'm
used
just
20. Then when I tried to populate the table, there was a particular column that says it was maximum. Then I had to take it back to 30. So I want to understand, how does it work? Like, how does it count this thing? Does it count it line character by character,
No.
or how? So you can determine how to do your size. Do you understand where I'm going to?
Yeah.
Because from the beginning of the table, I've been using 20 and it worked. Then on getting to the table booty, there was a problem there. Then I had to change it to 30. So I want to understand how it works.
Character size. It's actually in bytes. That's where the problem. I think the problem is this thing is in bytes, but in layman's term, we're saying is character length. Right? There is a calculation in bytes, but basically, I think in layman's term, we are looking at character length. I think what did I use here before? Okay,
You
3.
had, you had
Would
two.
you permit me to contribute something to that?
Yeah, sure.
Okay. Now, by default, right, the NVACHA will save like by one definition. Like it will just save the string length as one. But in a situation where you don't specify the character length, you understand, it's going to save it as 30. So if the length of your string is more than 30, it will truncate the rest of the information. You understand? So in a situation where you are not sure how many characters your string length is going to contain, just put 30 there by default. And remember that NVACHA uses twice the space. You understand? So you have
Yes,
to
please.
set
Hi.
enough you have to put enough
Just give me a minute.
you have to create a large field size for it to contain
Oh, that's
the
not it.
string length that you're trying
Sorry.
to put. Do you understand, Idris?
Listen. Yeah.
Oh, okay.
Yes. So by default, that's why you see that
But
30
hold on,
is.
what do you mean
What
by
number?
twice the size?
Now remember that when we checked NCHA and NVACHA,
Okay,
right, we saw byte 2 times the byte pair. For NVACHA,
okay,
we just save in byte pair. So whatever
okay.
NCHA is using, NVACHA we use times 2.
Okay. So does it mean that NCHA has a maximum size that can be imputed? You know, like
I
when you say it's twice the size, imagine I'm using NVACHA now, then I am assigning a size of 30 to it.
yeah 33.
And then for NCHA, I assign the size of maybe 10 to it. Are you
Please
with
come
me?
again. I didn't
Let
get
me
that.
just stop you here. See, as it concerns you and your daily struggles, right? As it concerns you and your daily struggle, this this is just maximum length. It's way deeper than what I just
Mm-hmm.
way deeper than maximum character length, storage
Mm.
size and stuff. But as it concerns your exam, this by December, this is maximum length. Do you get that?
Oh, okay.
At the end of like if you want to study in depth, then we are talking of storage size. One is bigger than one. Same thing we are saying with
Is there a way you can mute Vivian?
sorry, we are not speaking. Can you okay, thank you. As it concerns you, your exam and this course, this N is maximum. I was saying this N is fixed before, but that's wrong. This N is like maximum character length. If, as you can see from here, you can't like the max you can enter here is 3. 3 will go fine. Or anything other than 3. Okay. Same thing happens for NCHA. Same
Okay,
thing
can you
for
just ask Vivian to mute my mic because I can barely hear
who's that? Thank you. What was I saying? NCHA, NVACHA is That could disappoint. Storage size when it comes to bytes, we are talking of some kind of Unicode earlier, right? When it comes to those, every character on your keyboard, every character has an ASCII equivalent. It has a number equivalent, right? Which those number equivalents are actually also converted to binary. And the binary are converted to bytes, right? Which now gives you, okay, probably A is using 1 byte and one character that we don't know is using 2 bytes, and you get those kind of, but they are way, not something I want to start explaining in this class. Even me, I don't understand much of it, but I can use them, but I don't understand much of it. But the whole idea is storage space and some foreign characters that I'm sure you are not going to use. So, but as it concerns you, if you need more explanation, you can take it up and read it, and probably when you get it, you can give me a call and explain to me, please, if you can do that. But as it concerns this class, just note that these values here are maximums, like maximum character length, because I don't think you'll be using all those characters that are using multiple bytes. So they are character lengths. So MRS, you can't have another one in front because we said the constraint, the character length is 3. This is also a form of constraint. I don't know if you get that.
Yes,
Yeah. I just figured that out now by counting the amount of characters on the table I was trying to populate, and I realized I was actually
Counting characters. That is not the right answer, but as it concerns this class,
let's say woo to the answer.
counting the characters, but that's not the answer. If they ask that in theory and you put what I just told you, you will.
Because I actually counted, I realized I was 22 characters and I specified 20.
So just remove 2, it will work.
Okay. So when we okay, in layman's language, we can just summarize by saying it's about the byte space where Nka is smaller and Vacha is twice as much.
Yes.
Okay. Thank you. Yeah, I mean, I think for layman's as me and the rest of us, that is more than enough, at least to have that understanding. And from the cursor there, you're saying you have maximum length of character, where you have 4, it has to be okay. Now, when you talk about the maximum character values, so you see there from the driver's ID, you have 212, that is 3. So from the details there, that means it cannot be empty, that's clear, but it can have the maximum of 4. But 3 is fine, but
3 is fine, 1 is fine, 2 is fine, 3 is fine, 4 is fine, but 5 is not fine.
5 is not fine. Okay.
That was the mistake I made with my explanation earlier, saying it's a fixed value. It's not a fixed value. Both of them are maximum. The only difference is their byte size.
Byte size, yeah. Thank you very much. I think that was my first question. I'm sorry I dragged everyone into it. Now my second question, if I can please go on.
Yeah, sure.
Was on the cascade. Well, I think yes, parents, you delete parents, you delete the children as well. But what is that on update cascade? Is that means when you delete a child or children, that means the parents cannot be deleted? Is that correct?
This is on update. This is on delete. Like if we delete, what happens? If we update, what happens?
Oh, okay. So it is the same meaning that if you update a parent, that means you update children. If you delete it,
field on deliver also.
Okay, so both of when you delete and update. Sorry, both of them, because there is on delete cascade and on update cascade. That means when you delete and update the parents, the changes are also made to the children. Is that correct?
Right. Yes. So if you change the last name of, like, if your daddy changed his family name, if my dad changed our family name from Olasin to Adedigba now, That means me too, I will be,
I'm also affected.
my last name is Adediba, so that's just it.
Okay, well, thank you very much. I think, yeah, I was trying to get into my head that the way you explained. So I
This
think I'll explain.
separate statement, this is a separate statement. They are different. So this is giving an instruction when you update. This is giving an instruction when you, sorry, this is when you delete. This is giving an instruction when you update. Now, this cascade might be different for each one of them. They are separate instruction. I might say if I delete set null, if I update cascade, you get the instructions might be different. There are two different instructions. They are not the same. Hope you understand that.
Yeah, I get it. Delete and update, these are two different instructions, but I was talking about the action, the way they happens in the action.
The actions when you update the parent according to, because you are using cascade, it also makes an update where necessary. Not like it's updating by fire by force. It will update where necessary. So let's say we are using first name. First name is our foreign key here. So if I update this first name, let's say the first name was actually Anthony. So in our driver here, what we have is Anthony. When I update Anthony to Tony, this will also change because my on update says it should cascade.
Yeah. Yes. Thank you very much. That is what I was trying to get into my head.
Yeah. All right. Do you have any other question? Any other question? If there's no other question, I guess we'll see when we see. Have a good evening. Sorry, have a good day, everybody, and take care of yourselves. Right.
One more question, actually.
Thank you very much. We really appreciate.
Can we ask questions?
Sure. Go ahead.
Okay. For the constraint part, where we were creating our table. Now, in a scenario where we were creating a table that doesn't have a primary key, but referencing other tables that does, how do you do that?
You want to create a table without a primary key.
You understand? Like, let's assume, let us assume, like,
let's not assume.
Okay. So you know, in the lab 2, we're given tables, 4 tables: the pilage, the private, boot, and then booty. They all add primary keys. Then for the pilage table was getting its value from the other 3 tables. The pilage itself does not have a primary key.
So what's the question?
So the question is, if you are to do a constraint, how do you create a primary key for the table, or you just
Who you are referencing would definitely have a primary key because it's that primary key you want to reference. Does that make sense?
I don't think you understand what I'm saying. Maybe I'll send it to your WhatsApp. You see what I'm talking about.
No, you are saying your main table does not have a primary key, right? Like this.
Yeah. Like if you the self-tutorial too, the pilage table doesn't have its primary key of its own.
Tutorial 2. Sorry, if you're not interested, you can actually drop off. We are done with the class. Tutorial. This one, right?
Yeah. Now come down. You can see that the pilage key does not have a primary key of its own.
But nobody is referencing pilage key. No other person is connecting. Like pilage key is not a parent to anybody, is it?
Okay. So basically, I don't need to create any primary key for that. So then how do I connect? Do I just specify the constraints for foreign key without
That's it. Just specify your, like, okay, if you want to create this pilage now, what you want to do is this. Pilage. Then you want to have your P code, B code, BT code. P code, B code, PT code, right? Then your date, specifying your what's going on. You start specifying your foreign keys one by one. That's it. Foreign key that is using P code that is going to pirate, I think. Pirate that is using P code. Then you change the constraint name though. Then you have B code. What's going on with my keyboard? B code. That is going to booty, right? That is using B code on booty, right? And you have PT code. PT code.
Okay.
That's both. Let's just say both. That's both. PT code. That's it. No primary key because nobody's actually connecting to it. It's the one connecting to other people. But the point where somebody wants to now reference pilot code, then you need a particular field they want to reference.
Okay.
Does that make sense?
Oh yeah. I get it now.
Yeah. Any other question? Okay. Thank you, everybody. Have a good day.